All right, so we are gonna go into the last section, last part of 1.4, and we're gonna look at some scenarios. So, kind of draw this on your own. Okay, so let's look at this first scenario. The age of a human from birth to 30 years old. So draw a graph that represents this, where the independent variable is time in years and the dependent variable is age in years. Okay, so think about that. So independent, if you don't remember, means x. Dependent variable is y. So draw a graph with x and y so that x represents time and y represents age. How would that look like so that this graph represents a person from birth to 30 years old? Go ahead and pause the video and try that. Okay, so you probably drew something like this, right? I hope. So time meaning just the time, like right now it's 2020, and so that is just kind of the time, the year, and then age. So that's said. So say the person is born this year, and then until they're 30 years old, they gain 1 year of age every year it progresses. Or maybe some of you may think a little bit harder, and then you did something like this, which is totally understandable. That is a great thought, because maybe you're saying, really, let's say you were this person were born in 2020 January, then from January till December, you would still call that person, I don't know, 0 years old, because that person is they were just born, and then until the 2021 January, then that person becomes 1 year old. And see how here it says year is age is in years. So then this person, you wouldn't say like, yeah, he is one month old. He is like 2 years and 5 months old, because you're talking about years only. I guess you could say 2 point something years, but usually you just say that person is 2 years old, that person is 30 years old. So then you would just say that until you get to your next birthday, you're still that same year of age. So that is another way of thinking about it. That's awesome. Now, this question that has to do with the graph you drew. So the question is it guaranteed that there was some time t where the person was 17 years old? Is it guaranteed that this person, if this person had an age from birth to 30 years old, that sometime in his life, this person was 17 years old? Is it possible? Yes, of course, because this person from birth to 30 years old must pass through 17 years, and we know that as a fact, right? Okay, and then keep that in mind. We're going to talk about why that is important. Now, scenario 2. The height of a child with respect to days from 5 to 10 years old. Okay, so you're going to draw that graph. Again, independent variable this time is still time, and the dependent variable is height. So go ahead and draw a graph that you think would represent this. So how did you draw your graph? From ages 5 to 10, what is the height of this child? I'm not sure what you drew. So let's say this is 5 years old. Let's say this is 10 years old, and the dependent is the height. And so you may draw something like this, or you may have drew something like, I don't know, like this. So you're kind of saying like there was a growth spurt sometime between like 7 to 8 years old. So this kid grew really fast between that time, and then kind of flattened off. Or maybe you said the growth spurt came later and this kid kind of went like this. I don't know, but something kind of similar to that. Like you probably wouldn't draw something like this, right? Like this person doesn't magically become change from like say 3 feet to 4 feet in one day without something in between, like it just became something else. So then the question is, if this child were 3'8" at age 5 and 5'2" at age 10, that's a very tall child at age 10, is it guaranteed that at some point between ages 5 and 10, the child was 4 feet and 5 inches tall? Is it guaranteed? So the question is, if this person went from 3 feet 8 inches to 5 feet 2 inches, then is it guaranteed that sometime in this child's life he was at 4 feet 5 inches? And the answer is yes. And why is that? Because you can't, like I said before with that example, you can't just all of a sudden become some height without going through a height in between. So if we know in the beginning it was this, in the end it was this, and this person must have some time in his life was at 4 feet 5 inches. All right, let's say scenario 3. A car exits WCHS parking lot onto the beach boulevard at 10 miles per hour. 20 seconds later, the speed of the car is 45 miles per hour. So you're going to draw a graph. Independent variable is time. The dependent variable is speed. So go ahead and draw this car. How would this graph look like? He exited at 10 miles per hour. 20 seconds later, this is at 45 miles per hour. So this person exited at 10 miles per hour and then ended at 45 miles per hour in 20 seconds. So you probably would draw something like maybe this. He just accelerated the same acceleration. Or maybe this person sped up really fast and then slowed down to 45. Or maybe this person was going really fast and they had like a really super sports car and it went super fast and then came back down to 45 because they realized they're going to get caught if they go much higher than 45. So something like that. The next question again is it guaranteed that at some point between the car exiting WCHS and the noted time of 20 seconds later, this car traveled at a speed of 30 miles per hour. So if you know this car exited at 10 miles per hour and then 20 seconds later it was at 45 miles per hour, can you guarantee that sometime between this 20 seconds, this car was at 30 miles per hour? And again, the answer is yes. And why is that? You must, if you want to get from 10 to 45, you must have passed through 30. Now, why do you have to pass through 30 is the big question. So then let's look at the main big question about all three scenarios. What two conditions do all three scenarios have to meet? What two conditions do all three scenarios have before the guarantee is met? So we said the answer to all of these follow-up questions is it guaranteed, isn't guaranteed, and the answer is always yes, it is guaranteed. But then what are the conditions it has to meet before this guarantee is true? What does it have to happen so that we can say that, in the first scenario, this person, if the person was born until he is 30, he must have some time in his life became 17 years old. And then second scenario, if this person was 3 feet 8 inches at age 5, 5 feet 2 inches at age 10, and we can guarantee that this person sometime in his life was 4 feet 5 inches. Why is that? What is some condition that it has to meet before we can say that? And then the third scenario, saying that this car left at 10 miles per hour, 20 seconds later it's at 45 miles per hour. What is the condition it has to meet before we can guarantee that sometime in this 20 seconds this car had traveled at 30 miles per hour? Because if you watch some kind of sci-fi movie, you could morph yourself into a different time, right? Like this person could morph himself into 30 years old without passing through 17, or this person could morph himself from 3 feet 8 inches into 5 feet 2 inches without going through 4 feet 5 inches. Or this car could have traveled through time or something, and then, or what is it called, like teleport. So from WCHS front gate to somewhere in Beach Boulevard, and you didn't have to go through 30 miles per hour. So that could happen, right? In a sci-fi movie or something. But in real life, why does that have to be true? That is because the first condition, we know that the functions we're talking about is continuous. We would say that's absurd. How can a person go from 0 to 30 years old without going through 17? And why do we say that? Because age is continuous. You have to go through time just 1 second at a time. You cannot jump ahead or go backwards. That's what we understand about time. And same thing with the height. You have to grow through a certain height before you get to the next height. You cannot just all of a sudden skip 5 feet or something. And then same thing, your car must go from a certain speed to the next speed, going through the intermediate speed without, if you don't do that, you cannot get there. And that is because the function is continuous. So that's the first condition. The second condition is that the two endpoint must enclose the point of intent. What does that mean? So let's say we take the first scenario. So I'm saying that this person grew from birth to 30 years old. Then if I ask a question that says, is it guaranteed that this person will reach 40 years old? You would say, I don't know. Because 40 years old is not in between 0 to 30. So this person may not have lived past 30 and to reach age 40. So then 40 is beyond the two endpoints. So then we cannot guarantee that. And same thing with scenario 2. So the question is, this person started at 3 feet 8 inches, ended up at 5 feet 2 inches. I should probably just do this. Started at 3'8", ended at 5'2". Is it guaranteed this person has passed through 4'5"? Yes. But if the question says, is it guaranteed that this person passed through 6 feet, like this person went to 6 feet and shrunk? We don't know, because it's not through the endpoints. Okay, and then so same thing here. Scenario 3. If this car went from 10 to 45 miles per hour, is it guaranteed that it has to pass through 30? Yes. Is it guaranteed that this has passed through 60? We don't know. Yes, it's possible, like the green graph I drew here, right? Maybe they sped really fast and went up to 60, but it is not guaranteed. So what is guaranteed? Whatever is enclosed between the two endpoints, in this case 10 to 45. So this is the theorem we're going to talk about today. So just like the example we did before, we're going to talk about intermediate value theorem. Intermediate value means the number that's in between the two ends. And this is called the existence theorem because you're not going to use it to solve anything. You're just using it to prove something. And this is going to be the first theorem we're going to do this year. The first semester, we're going to have 3 theorems, and then the second semester, we're going to have 2 with some addendum. Okay, so intermediate theorem, value theorem, the first thing is, to use it, you have to have 2 requirements. First thing is, f is continuous on the closed interval a to b, where f of a is not equal to f of b. So that's the first requirement. This function is continuous on some closed interval a to b. When we talk about theorem and when we talk about things where you have kind of like ideas to apply to something else, you always have to ask yourself two things. Is this function continuous? Can I only use it when it's continuous? Or can I use it anytime I want to use it? And what kind of interval can I use it on? Closed interval or open interval? So you always want to ask yourself those two things. Okay, so that is the first requirement for this theorem. The second requirement is K is any number between f of A and f of B. So f of A and f of B are the y values, so K is a y value that's between f of A to f of B. If this is true, then there is at least one number C, or let's say x equals C, in A to B such that f of C is K. So there is a number x equals C between the interval A to B so that f of C is equal to K. Okay, that is a lot of information, so I'm going to show you graphically what it actually means. So I'll put it on top. So first, f is a continuous function on the closed interval A to B. So let's say this is A, this is B. We have a function between A to B that is closed. So something like that. Oh, it's a little farther. So A to B, closed, continuous. So that means there's no break in between. All right, and it tells me that f of A cannot equal f of B. So that means I cannot have something like this, where these two are the same y values. So they said that's not okay. Okay, so this is the first requirement. And the second requirement is that K is a number between f of A and f of B. So this is f of A, right? This is the y value of A, and this is the y value of B. And then K is somewhere in between f of A to f of B. So they're saying that if these two requirements are true, then you can make the conclusion that there must be at least one number x, which is C, in between A to B so that f of C is K. So they're saying that if K is in between A to B, so then you can kind of say like this whole line, horizontal line, represents the level of K, right? Then there must be at least one value in this function, right? We have actually three values, where if you plug those x values into the function, you're going to get K as well as the y value, which is true. Now, why is that true? This is very intuitive. So if you kind of just think about like a very normal function, let's say that I tell you this function, on one end it stops at -1, on the other end it stops at 2. Okay, so one end it stops at -1. On the other end, it stops at 2. I tell you that this is a continuous function, so it's closed in between. Then I ask you, is it guaranteed that it will cross the x-axis? Of course. You're going from -1 to 2. X-axis means the y is 0. If you want to go from -1 to 2, you have to go through 0. This is guaranteed. Unless you jump on this function, right? If you jump on this function, then there is no guarantee. If it's not connected, then there is no guarantee that you have to cross. But if it's connected, then of course you have to cross the 0. So that is what the intermediate value theorem is talking about. Now, let's go ahead and use the intermediate value theorem to prove. So let's look at this question. Let's say that you have this function. You want to use intermediate value theorem to prove that there is a 0 between x equals 1 and x equals 2. So in order to apply, we need to check those two requirements. So remember those two requirements? First thing, the function has to be continuous between closed intervals. And then the two ends cannot equal the same number. So look at this function. Is it continuous between the two ends? Yes. And why is that? It's a polynomial. Polynomials are always continuous, and you don't have to prove that. This is a general knowledge that polynomials will be continuous, so you don't have to prove. So you can just kind of say to yourself, this is not a proof. This is just for your own knowledge for now. And then you do have a closed interval between 1 and 2. The second thing you're going to do is check f of 1 and f of 2. You're checking to see, are they the same value? If they are, then there is no guarantee. And this next thing is, you're checking this k value, in this case is a 0. Is it in between f of 1 and 2? All right, so let's check. 4 times 1 cubed minus 6 times 1 squared plus 3 times 1 minus 2. That is 4 minus 6 plus 3 minus 2. And that is -1. Now let's put 2 in. 4 times 2 cubed minus 6 times 2 squared plus 3 times 2 minus 2. That is 12. So is 0 in between -1 and 12? Yes. Remember to check it against the y value, not the x value, okay? So yes, 0 is between -1 and 12. And so we can say that in this function between 1 and 2, it must have passed through 0 at some time. So let's write the conclusion. This is kind of what you need to prove. So all this work that you are doing here is great, but you also have to write this statement. Since f of x is continuous between 1 to 2 and f of 1 is less than 0, less than f of 2, according to IVT, there is a at least a number x equals c such that f of c equals 0. So let's look at our answer here. Since f is continuous between a closed interval, that is condition number 1. Condition number 2, the number we want is between two numbers and they're not equal. According to IVT, the conclusion is supported. Okay, so this is what you need to write for every IVT problem. Let's look at another kind of question. So first, decide whether or not the intermediate value theorem can be applied to the given function, value, and interval. Justify your decision carefully. When this theorem applies, state carefully what it concludes. All right, so this first part is use the IVT. So check the two conditions. If it does apply, write the correct conclusion. Next, if it does apply, then find that C value so that it equals K. So there are two parts to this question, 1 and 2. All right, so first part, use the IVT to check whether this actually works. Okay, so the first thing is we check to see if intermediate value theorem applies to this, which is saying, is it continuous between the closed interval? Well, this function is not a continuous function, but where is it not continuous? It's not continuous at this denominator, x equals 0. But is x equals 0 in my interval? No. We're only looking at the interval 1 to 3, therefore this does not affect my continuity. There is a discontinuous function, but it is not in the discontinuity is not in the interval that I care about. And so we would say that f of x is continuous within 1 to 3. Okay, we don't care about x equals 0 because that's not where the interval is. The second thing is check the two ends. 1 squared plus 8 over 1, that is 9. And then 3 squared plus 8 over 3, that is 17 over 3, which is about 5.66. So is 6 in between? Yes. 6 is in between. F of 3 is the smaller, and then F of 1 is the bigger. Be careful of that. It's not always the first one is smaller than the second one. So can we apply IVT? Yes. So we can say since f of x is continuous between 1, 2, 3 and f of 3 is less than 6 less than f of 1 according to IVT, there exists at least one x equals c such that f of c is 6. All right, that's great justification. Second part. Then what value of x is going to give me 6? Well, that's easy. You would just try to solve. So f of c is going to be c squared plus 8 over c. We know it has to equal 6. We just don't know what c value it is. So we're going to solve. So this one we can do it two ways. One is algebraic. The other one is graphical. So I'm going to show you how to do this algebraically. When you first see this, you probably forgot all your algebra of how to solve this. So it's very easy. You're going to first multiply both sides by c. And then you're going to make it equal to 0. Then you try to factor. So c is 4 or 2. But remember, we're looking at the interval between 1 to 3 only. So the answer is just 2. Pretty easy. Now we're going to do this graphically. You may not get very lucky like this and be able to solve the problem algebraically every time. So I'm going to show you how to do this graphically. The fastest way to solve this is to make it equal to 0. And then what you're going to do is you're going to assume this is a function. So then you would type that in the calculator. Of course, you're not going to type in c, you're going to type in x. And what you're doing is you're saying, when is this equal to 0? 0 basically means the x-axis. So you're just going to graph it, and then you're checking where does it meet the x-axis. And hopefully you remember from last year in pre-calc, you would use the second and then go to trace. And then one of the functions in there says 0. And then you use that left bound, right bound to figure out what the 0 is. And then remember that you're still within the closed interval 1, 2, 3. So then you want to set the calculator so it only shows you 1, 2, 3. And then to do that, you would go to window. And then in window, when it says x min and x max, basically you want to set it so that it's just 1 and 3. So then you don't see more than that, or else you may get confused. Okay, if you do that, you're also going to get the same number, x equals 2. All right. Now is the time for you to practice. So looking at this function here, actually, let's change it so it's a little easier to do. Let's say that f of x is equal to x plus 1 over x. K equals 2 between the interval -2 to 2. So the question is, first, does IVT apply? If it applies, then write that conclusion. If it doesn't apply, then write why. And then the second is, if it does apply, then what is C? All right, go ahead and pause the video and try to solve this problem. Hopefully you saw this really quickly and you realize that actually it's not going to work because there is a discontinuity at 0 and 0 is in between this section. So then you would say that IVT does not apply because f of x is not continuous between -2 to 2. And then so there is no need to solve for this part because it is already not continuous.